In the last part, we looked at some data and frequency tables. And we looked at how you calculate the mean, median, mode and range from data in this format. And we did an example. The mode was quite straightforward. It was the highest frequency and the corresponding number of siblings. The median was the middle value for siblings, which we found by going halfway into the data from either side. The range was the highest number of siblings, take away the lowest number of siblings. And then the mean, and this is the key one, was the sum of the values divided by the number of values. So we worked out the total for each row. These 4 had no siblings, these 6 had 6 siblings. Then we totaled that up. When we divide that by the total number of values, we get our mean. Now let's imagine a different situation. There is a car. In fact, there's loads of cars driving along a road. And what you're measuring here is, we're measuring when cars leave work. So it hits 5 p.m. When after people are allowed to sign out of work, do people actually go? And there's an office building that we're measuring this for. I know my drawings are terrible, and this is a weird looking office, isn't it? So, let's do some analysis for the company. But there's a problem. Recording the actual time people leave is really difficult. So here's what I'm going to do. I'm going to look at the time it takes people to leave. In fact, I'll come down here so I have more space. And I'm going to record who leaves in the first 5 minutes, which I'm going to write like this. So from 0 minutes up to 5 minutes after, but not including the 5 minutes. I'm then going to count how many leave in the next 5 minutes. And my method for counting is this. I'm going to stand there, set my watch to beep every 5 minutes, and literally count the cars that whiz by. 1, 2, 3, 4, 5, 6, 7, 8. Not really quick. And because I'm counting so fast, as they whiz by, I can't actually record the exact time they leave. So this interval covers for the fact that I can't record the exact time, because lo and behold, when I wrote it down, there were loads of them. There were 27 left in the first 5 minutes, and there were another 32 that left in the next 5 minutes. Too many for me to record the actual times. Then things started to slow down. So I recorded the next 10 minutes as an interval. Only 15 left. And then, in the next interval, all the way up to an hour after everyone finishes work, there were 6 more. Now this workplace is really good because most people get out really on the dot. Fantastic. So, can we now investigate this data? What can we find out in this information? So, you know the 4 things we're looking at normally: mean, median, mode, and range. But there's a problem with our data here. How are you going to be able to tell me anything when you haven't actually recorded the specific value for any piece of data? We've only got the interval, not the actual value. Well, let's see what we can do. Now the mode. We can find the modal class interval. The most common interval. Now, this will have the highest frequency, which is 32 here. So the modal interval, the interval where most cars left in, is that. Okay, so far so good. Range. The highest value take away the lowest value. I'm afraid that's going to prove impossible because we don't know any of the actual values. And it's not a very good idea, given our intervals, to estimate them either. Not for a range. We can find a median. We'll do that last. But the most popular one to do in this situation is the mean. Do you know any of the actual values? No, you don't. So the best we're going to be able to do is estimate the mean. So let's have a look at this now. If I was to try and estimate what these values here, these 27 car times were, what would be a sensible way of estimating them? They all left in this interval. Well, the sensible suggestion would be 2.5 minutes. Halfway into the interval. That is the midpoint. Now, we don't know that that's the case. They could have all been just at this end. They could have all been bang on the dot at 0. But the middle is a safe bet. And we'll do the same here. The middle value, 7.5 minutes. Now, if you want to find the midpoint of two values, you add them and divide by 2. So 5 add 10 is 15, divided by 2 gives you 7.5. Do the last two midpoints now. So 10 add 20 is 30, half it is 15. 20 add 60 is 80, half it is 40. So now we've got an estimate for each value. And now our table, using these two columns, can be used a lot like the previous table. Frequency and midpoint, if we look back at the previous one, are now the equivalent to frequency and siblings. Well, this was the actual value, and this is an estimated, but that's the best we can do. So we're going to need to find the total for the rows, because remember, the mean is sum of the total for the rows divided by the sum of the frequency. So, for the top row, there are 27 values, each worth 2.5. So that's 67.5 in total. For the second one, there are 32 values at 7.5. For the third one, there are 15 values of 15. And the last one is 6 values of 40. So our total is 772.5. And we divide that by the sum of the frequency, which is how many cars there were in total. So our estimate for the mean, it can only be an estimate because we don't actually know the time that any of the cars went, is 9.65625 minutes. Now that needs rounding, so we'd probably go 9.7 minutes. But what we've got here is a clear method for where we take the midpoint of the interval, we use the midpoint and the frequency to get our row totals, and then we do the sum of the row totals divided by the sum of the frequency for an estimate of the mean. So you now need to think this through, pause, check, and then go and try some questions until you feel confident. And we'll look at estimating the median in the next video.